Good morning, everyone, and welcome to XBOSoft's quarterly webinar. And for this quarter, we have a special guest speaker, Peter Varhol. He's going to be talking about what air crews can teach testing teams. So I'm really excited to have Peter share his knowledge with us. As we know, there's lots of stuff going on in the airline industry that I'm hoping that we can learn from. So welcome, Peter.
Thanks, Phil. Thanks for having me. I really enjoy the prospect of being here.
Great. So let's move on here. And so, firstly, a few house rules. So we're going to be recording the webinar, and you'll be able to receive a copy of the recording or a link to the recording later on. As far as XBOSoft's concerned, we have a quarterly webinar every quarter, and we have a special guest speaker, such as Peter. We also, in our free time, we do software testing as well as software QA consulting. We're an international company. Most of our clients are located in the US and in Europe. Go to the next slide there, Peter.
Trying here. There we go.
Okay, we'll get the hang of it here. For those that are attending, please feel free to ask questions in the chat panel or in the question panel, and you will receive the slides as well as the link to the recording. Go on, Peter. Myself, I am the CEO and founder of XBOSoft. You can look me up and find me on LinkedIn. What's not there on LinkedIn is that I'm really passionate about cycling and travel. And I believe I've traveled to over 70 countries, although I've lost count. I really use travel as a way to satisfy my thirst for learning and experiencing new things, new foods, and meeting new people. Like Peter, that's how I met Peter several years ago in my travels for work stuff, and I'm glad to have Peter here. Let me introduce Peter.
And you've got more countries than I do, Phil.
Okay, great. So Peter, our guest speaker, Peter has been flying since he was 17. Is that right, Peter?
Actually, I've been flying before that, but I got my private pilot's license at 17.
Okay.
We'll see that on the next slide.
You got your license at 17. Wow.
Yes.
So you've been flying for about 3 years now. So you're.
That's okay. So you stole my line, but I actually was going to say I started flying in 19 mumble.
Okay, and you. Besides all the stuff that they can find out about you on LinkedIn, I didn't know that you were actually a former university professor. What kind of things did you teach?
So I actually was a tenure track professor. I taught computer science and mathematics and was department chair for a couple of years too.
Okay, wow, that's and a cat owner as well.
And you probably didn't know that I was a cat owner. There they are, and a distance runner. The photo you see is finishing my first half marathon in Reykjavik, Iceland.
In Iceland, wow.
Yes.
Okay, and how was that? Is that pretty recent?
That was about 3 years ago.
Wow. Okay, that is very recent. Well, congratulations. Are you? Do you have your sights set on a marathon?
No. I've done 2 half marathons. I have a 5-kilometer scheduled for next week. It's 10 kilometers scheduled for August, and as those are probably my distances right now.
Okay, well, that's cool. And you do a lot of speaking as well. I remember meeting you in Spain speaking.
Oh yes.
That's fantastic.
And this past spring in Chicago too, at Quest, at the Quest conference.
That's great. What did you speak on at the Quest conference?
So my collaborator Jerry Owen and I spoke on developing personas. I believe you sat in on that one,
right?
Actually.
Right.
And we also had another topic that's escaping me right now.
Well, I'll let you take it away and talk about how we can learn from pilots and air crews and how it can help us in our testing. So, go
Sure.
ahead.
So, as Phil alluded to, I got my private pilot's license at 17. Actually, soloed before I had the day after my 16th birthday, which was before I got my driver's license. So, I was so excited about flying growing up. And unfortunately, the reality did not meet my expectation. I discovered, to my chagrin, that flying was boring. I couldn't do barrel rolls. Well, I may have tried one once. I don't think there's any record of that. And flying consists of just checklist upon checklist upon checklist. Every time you want to go up in the air, you go through the same ritual every time. I grew up seeing on TV pilots hopping into their airplane, starting the engine, and throttles to the wall, and taking off vertically and getting away from the bad guy. So it's not at all like that in practice. You go through the same ritual. You walk around the plane. You look at the propeller. Is there any damage or nicks in the propeller? You look at the wings. Is there any damage on the wings? You walk around the plane, the other control surfaces. You actually physically move the control surfaces to make sure they move freely. You pop the engine cowling in front, and you check the oil. The fuel is typically in the wings, so you check the fuel, physically eyeball the fuel in the wings, and only then do you get in the airplane. So once you get in the airplane, you've got another checklist. You've got your pre-flight checklist. You've got to start the ignition, check your magnetos, your flaps, your control surfaces, once again from inside the plane, and the instruments. So what I discovered in learning how to fly, not only is flying boring, but it came to me later in life that flying is supposed to be boring. Because if flying is exciting, that means you're in trouble. So let's actually see what that means from the standpoint of flying. Um, and Air crews right now use a technique called crew resource management, and this developed because we learned back in the 80s, 1980s, 1990s, that accidents occurred primarily because of crew inattention, poor communications among the crew, and a lack of teamwork. Um, as a result, people died, and the airlines needed to address that. And technology and automation have helped over the years, although we'll see later on in the presentation that also sometimes they've hindered. So talk about complexity. Um, Pilots deal with one of the most complex environments imaginable. I think this is a relatively old cockpit. It's a mainline airliner cockpit. I think it's a relatively older cockpit because a lot of those instruments have been replaced by digital instruments right now. But it's still very complex, and they have to deal with this complexity. They have to know not only what every one of these things does, but they need to be looking at every single readout almost constantly to make sure that things are where they need to be. Is crew resource management effective? Is this technique, and I'll talk about this technique in a little bit, is this effective? Well, here in the United States, you may be interneting in from anywhere in the world, but here in the United States, in 2009, there was a crash by Kogan Airlines, Kogan Air Flight 3470, a commuter airline basically. The crash outside of Buffalo with the loss of 49 lives. Last year in 2018, there was a Southwest Flight 1380, and you may remember this one because it's got a lot of play, especially in the United States. Suffered a catastrophic engine failure. The engine really blew up. Apart from the engine, cracked a window, and that person was partially sucked out the window, causing the death of that one person. But the really amazing thing about all this, and you see the image down there that I had, this was actually an image from the Miracle on the Hudson, the U.S. Airways flight that had a bird strike 29 seconds into flight leaving LaGuardia and ended up in the Hudson River. And this was an incident. You see all the people standing on the wings there in the rafts. This was an incident that nobody died in, which was really good. So these two that I mentioned here were the only fatalities on U.S. carriers during that 9-year period. So why should we as software testers care about this? Well, I think it's a given that software is expensive to build. Even many applications, even many internal applications that are built by IT are multi-million-dollar projects. In addition, software is increasingly being used for safety-critical systems. Airline systems, autonomous vehicle systems of all types, including self-driving cars. So we're seeing an increasing use of software where if it fails, people can die. So software has, and unfortunately will continue to kill people. We need not necessarily better software, but we need people systems to mitigate this damage. The idea of thinking about people systems while you're doing your testing should be one of the central roles of the testing function. So I'm going to start, now this was back in 1988, so this is a while ago. This was United Flight 232. It was a DC-10, and you see it had 3 engines, 2 on the wing and 1 in the tail. This particular flight in 1988 was flying from Denver to Chicago. Somewhere over Nebraska, the rear engine, the one in the tail, suffered what airline people, aircraft people like to refer to as a catastrophic failure. Basically, it blew up. So that blowing up took out the primary hydraulic system of the airplane. Airplanes were controlled primarily through hydraulic systems at that point, which means that basically they had pipes going from the pilot and co-pilot controls back to the control surfaces, and they had fluids in them, and as they moved, the fluids pushed a control surface in one way or the other, directly in response to what the pilot or co-pilot were doing. So this particular engine failure took out the primary hydraulic system. However, it also, because of where it happened to be located, took out both of the backup hydraulic systems. So imagine that you're in your car and you hear an explosion, and you're going down the highway at like maybe 65, 70 miles an hour. You hear an explosion, and you try to, you hit the brakes, and the pedal goes all the way to the floor. Don't laugh, that's happened to me before. The pedal goes all the way to the floor without stopping the car. And then you pull the emergency brake, nothing happens there. So you try to steer it to the side of the road, and you find out you can't steer either. This is what they dealt with, not in the 2 dimensions that we're used to, but in 3 dimensions. So literally, there was no way to control this aircraft. Furthermore, they're still in the air, and they're flying more or less straight and level. United and the aircraft manufacturer, McDonnell Douglas, told the crew it was impossible to lose all control. It could not have happened to you, so we don't have any procedures for it. Well, that was useful, wasn't it? So this is it. We're going to die. However, the crew came through in a crisis. Now, literally, they had no way of controlling this aircraft. Up, down, side, one way, one direction, the other direction. The only control they had was the 2 operable engines on either wing, that if they pushed the right throttle forward, the plane would tend to turn to the left. If they push the left throttle forward, the aircraft would tend to turn to the right. And that was all the control they had. So they had 4 qualified flight crew on board: captain, first officer, flight engineer, and 1 off-duty check pilot who I bet regretted that he, in fact, got on that plane to begin with. So they establish a very minimum of control using only that engine thrust with the starboard and port engines, with the left and right engines. They divided responsibilities among the 4 of them. Somebody worked the radio, talking to ground control, talking to air traffic control, talking to United, talking to McDonnell Douglas. The throttles, turn and bank, other instruments. They did some damage assessment, and they also exchanged ideas. So the end result is that this plane that should have crashed with no souls left actually did a crash landing, and they actually brought it in very well, except that aircraft that don't have any control, that they were the first people to discover, tend to exhibit what they call up and down behavior. So it would start in an up and down. So that's why this is a crash landing. People still died. I think it was 111 out of 319 people died, but most lived. No one should have lived through this. So what happened here so that this plane just did not nose into the ground? Most of the accident investigations on this cite the professionalism, respect, and innovation of those 4 aircrew. The willingness to admit that they didn't know what to do, but they kept trying things, and to trust and rely on each other's skills with their lives. This is another example, another story. Asiana Airlines Flight 214. In 2013, this crash landed at San Francisco International Airport. So what happened was that the captain configured the plane for landing. He made several errors in doing so. He inadvertently shut off the auto landing autopilot feature, which also shut off the auto throttle feature. So the engine power went to idle, but he didn't notice. The crew may or may not have noticed, but they were unwilling to question these errors that the pilot made. So the end result was that this crash landed just short of the runway, partially on the runway, partially in San Francisco Bay. 3 people died. There were a number of injuries, in the case of what should have been a normal landing. And the result was, end result was that what happened was that the accident investigation team determined that over-reliance on automation, and we'll talk about this a little bit later too, and the lack of systems understanding was really the main contributing factors. The crew didn't realize, or the captain didn't realize that the plane would go to auto throttle. The auto throttle would shut off the engine power, and that the crew, the first officers who were on board, did not feel that they could question the captain. The captain here was the final authority, and the crews were to respect the captain's expertise and to not question him. But the captain can't be an expert in everything. The captain's human, after all. But the captain can't know everything, but we're taught not to question authority in many cases. We're not good at doing that. We're not good at questioning authority, in other words. So why do accidents occur? Accidents, I'm going to say, are primarily caused by the inability of crews to respond appropriately to the situation in which they face themselves. I say here, mostly human and crew error. Phil, I'm going to come back to you right now and talk about the recent Boeing 737 MAX crashes And I'm going to say that yes, the crew was not able to recover from an unexpected situation, but the fact that that was an unexpected situation falls primarily upon Boeing. What do you think?
Is that because the software was bad, the design was bad, or maybe
So
the reaction
I think
or
that
the education, right? They talked about that as well.
I think that the software worked as designed.
Mhm.
I just think that it was a poor design in that Boeing did not design any backup systems. They did not appropriately document this situation and the things that the crew was supposed to do. And most important, perhaps they didn't require training of the crew in these procedures. So what really happened here, okay, so what really happened was that the Boeing 737 MAX aircraft contain a computer that tries to determine whether or not a aircraft is about to stall. Now, stalling is not the same as an automobile. Stalling in an aircraft is you reach an angle of attack. In other words, you angle up too high for the airfoils for the wings to get lift. Once the wings lose lift, that's a stall in an aircraft. So they designed a system such to recognize whether or not a stall would occur and to push the nose down without the intervention of the crew. However, what happened here was that there was a faulty sensor that believed that the aircraft was stalling when in fact it was not.
Mhm.
And so irrespective of what the aircraft was doing, the system would push the nose down. That under normal circumstances might be a good thing, but the sensor failed, and the sensor was flawed, and the sensor fed inappropriate data to the computer. Furthermore, Boeing expected the crew to be able to immediately recognize the problem and to respond to that problem within seconds. Now, both of these crashes, the Ethiopia Air and the Lion Air flights, happened shortly after takeoff, which is one of the busiest times of the flight for the flight crew. So you throw in the fact that you're very busy as a crew member right now, and then all of a sudden your aircraft noses down, seemingly without explanation, without cause, without anything. Are you really expected to recover, identify the problem, and recover within seconds? Apparently, Boeing did expect the flight crew to be able to do that.
Well, the thing is, Peter, is that thousands of other flights didn't crash.
They didn't because it was a faulty sensor was what it is. Those had sensors that worked okay. So the other thing that Boeing did not do is that the system was designed with two sensors, but it would fail if one of the sensors failed. They didn't have a failover, so to speak. There was not redundancy in the system, which is a major design error for just about any safety critical system that you would like to imagine.
Okay. Well,
So that's kind of now. Okay, so I'm an aviation enthusiast. I have no special knowledge as to what happened here. So and the crash reports haven't been published yet. So I'm part of what I'm telling you is speculation. But this seems to be what has happened here. And what we've done, what Boeing had done here, is that they've taken I'll say a very busy time of the flight, and through a single electronic failure, through a single sensor failure, all of a sudden doubled the workload of the crew. And so the crew did not have any idea of what was going on, let alone how to fix it. And they had seconds to respond. So this is one place where crew resource management comes in. It's a management system that helps the crew make optimal use of all available resources to make flight operations better. I have a link here, and Phil said he's going to be supplying the slides, so that's all great. So how does this help? Well, the captain still has final authority. The decision's still on the captain, but the captain is required to listen to everybody in the cockpit. And subordinates in the cockpit can question what the captain has to say, those decisions and things like that, and not get into trouble for doing so. For years and years, actually for decades really, in aviation operations, the pilot was the sole authority, kind of like the captain of a ship. And if you question the captain, that could harm your career. So when airlines started adopting crew resource management, they started training people, you should be able to question. And you actually, in some circumstances, must be able to question. So how does this work at a very high level? A crew member starts with an opening or attention getter, stating the concern, stating the problem, stating a solution, and obtaining agreement. So how might this work in testing? I have, once again, a very simple scenario here. Susan, who's the test lead or test manager, do you have a moment? This group of tests is exiting with a fatal error. I can't tell if the problem is with the tests or the application, but we're blocked until we can address it. I think we need to run the test manually. Here's the proposed solution until we can find the problem. It will take a little extra time, but we can't continue like this. Does this work for you? That's obtaining agreement. Now, like I said, that's a pretty trivial discussion, but it's respecting Susan as a decision maker. Susan, on the other hand, is respecting the person who's doing the testing for what they have learned and what they're suggesting. So what are the lessons to testing from aircrew resource management, from aviation in general? Well, first of all, stuff happens. Second, a sense of humor is essential. You can't take everything seriously. Use the skills of your entire team. Automation, even though automation in many circumstances is wonderful, can also be a crutch. We need training, and last but not least, use those checklists. So stuff happens. In United Flight 232, all 3 hydraulic systems were registering 0. There was no hydraulic fluid. The hydraulic systems were destroyed. It's a disaster. We can't control the plane. In a testing world, something equivalent might be, hey, our app just failed in production. Our cloud facility just went offline. Or we can no longer see what's happening within our application. And the way that you prepare for that is training and practice. Because I'd like to go back and you can get these on YouTube if you like, but I like listening to some of the radio communications that happen in aircraft when they have disasters, like the Miracle on the Hudson with Sully Sullenberger and the bird strike 29 seconds into flight and going in the Hudson River. The thing that I find amazing, well, I find a couple of things amazing. The thing I find amazing about that, first of all, is that Scully Sullenberger had never, and his co-pilot had never met one another before that morning. So they had to fall back on their training. They had to fall back on what they practiced without having a, I'll say, working relationship amongst them. The other thing that I find really amazing, and if you listen to that record, it's an amazing recording. So they're talking, everybody is calm, cool, and collected. The air traffic control, the tower at LaGuardia, the pilot and co-pilot. So they're asking, can you get back to runway 4 at LaGuardia? Can you divert to runway 1 at Teterboro? And Scully finally says, nope, we're going in the river. Like he's ordering coffee from Starbucks. That calm, cool, and collected. There's no excitement at all in there. So the way that you do that is that it becomes part of your training. It becomes part of your practice. Don't lose your focus. Don't get all excited and not go through your checklists. A sense of humor is essential. In the case of, once again, United 232, United 232 heavy, and heavy means that they still have a pretty heavy load of fuel there. The wind's currently 360 out of the north at 11, 360 at 11 knots. You're cleared to land on any runway. The Captain Haynes replies, Roger, you want to be particular and make it a runway, huh? So you need to find an occasion to laugh. You just can't focus on, oh God, we're going to die. If no one's going to die, you got to be able to laugh at something. Levity is appropriate in any tense situation. Use the skills on your entire team. Captain Haynes was quoted afterwards as saying, we had 103 years of flying experience in the cockpit, trying to get that airplane on the ground, not 1 minute of which we had actually practiced. So why would I know more about doing that under those conditions than any of the other three? And the most important thing I think that we need to remember as members of a testing team is that every team member has contributions that matter. Teams need to prepare for disaster. You should practice crises. They could be real or simulated. You practice and you find out what those skills that your team members have. Let one team member perhaps devise scenarios, and the more complex they are, the better. We're having a distributed denial of service attack. Our DNS is down. What shall we do? The more intricate you can make it, the better. If you're practicing it, you can take the time to talk about it, but guess what? If and when it really happens, then you've already been through it multiple times. So this is one last example here. This is Air France Flight 447. In 2009, it was going from Rio de Janeiro, Brazil to Paris, France. It encountered some bad weather over the Central Atlantic and went down with all souls lost over the Central Atlantic. The flight crew included a captain and 2 first officers. During that bad weather, it turns out that the autopilot, their sensors were not receiving valid airspeed and altitude information. So the aircraft automatically went to a lower level of automation. The pilots had to do some flying here. The first officers lost situational awareness, and I can't tell you also about how much situational awareness counts in a crisis. So the first officers didn't realize what was going on with the aircraft. They kept believing that their airspeed was getting lower and lower and lower, and they started, or higher and higher and higher. So they started climbing and climbing and climbing. So the airplane literally lost its lift and fell into a stall and fell into the ocean from 39,000 feet. The telling thing, I think, here is that the airliner had been in the air at that point in time for about 3.5 hours. In that time, 3.5 hours, it had been flown manually by the pilots or first officers for a grand total of 3 minutes. So the lesson here is that automation can be a crutch. Automation is great, and this definitely applies to testing too. Automation is great for consistency in operation. If we want to run regression tests and we want to do exactly the same thing again and again and again, day after day after day, automation is great. However, when things start going wrong, the automation gets in the way of our recognizing when things start going wrong or when something unexpected happens. So automation failures in aircraft can produce catastrophic results. And I've given you one example here, but actually I've given you two examples because the Asiana Flight was that way too. So I saw a writer, a keynote speaker by the name of Nicholas Carr. Nicholas Carr is rather well known in the IT industry. At the beginning of the millennium, he published his first book called IT Doesn't Matter, which was very controversial. And I've done my share of criticism at Nicholas Carr. But I saw him give a presentation at a software testing conference a couple of years ago. And one of the things, he really struck me as really understanding the problem here. One of the things that he said was you can't automate something that you can't do yourself because you won't be able to tell whether or not you succeeded. If you have not done it manually, if you have not done 2 + 2 = 4 on a paper and pencil when you're maybe in kindergarten, then you can't tell if the calculator is giving you the right answer. And it's the same way with automation and testing. You can't tell if your testing is being done correctly if you haven't first done your testing manually. We need training. Sorry, the image there is overlapping some of the text. We'll fix that. In systems and software, yes, but we need training in communications and in recognizing and dealing with crises, knowing when a situation is going bad and practicing it enough to be able to react calmly and accurately. Checklists. Checklists are part of our daily lives. Checklists, aviation, air crews use checklists all the time. I remember an example that I read, this was about 3 or 4 months ago now, that an air crew took off. It was an airliner and commercial airliner. They took off, and about 20 minutes into the flight, the passengers started getting sick and started feeling lightheaded and started throwing up. Come to find out that they did not turn on the pressurization. The cabin was not pressurized. They climbed up above 10 or 12,000 feet, and people started feeling lightheaded, getting nauseous, and things like that. Now, I'm sure that that is a checklist item, and they did not go through their checklist. Checklists relieve the cognitive load of trying to remember to do that. So at that point in time, they didn't do their checklist, obviously, and they didn't remember to do a very, very important part of what they should do in taking off and flying the plane. It helps us to organize complicated decisions and reduce risk. Checklists can replace, in testing, they can replace test cases. They can supplement test cases. We can have a checklist on what is the configuration of the hardware we're supposed to use, what is the configuration of the software we're supposed to use, what version of operating system, what version of library, and things like that. We can vary entry and exit criteria, do our ambiguity reviews, and help us estimate how long testing is going to take. There's various types of testing. Go ahead, Phil. I'm sorry.
You know, as a lot of people have been talking about checking versus testing, and can you elaborate on that? I mean, so checklists are not something that testers should do, I guess, is what people are saying.
I think that what people are saying, and you know, I know several of the people who are saying that. I think Michael Bolton is one of the particularly vocal people in checking versus testing.
I didn't want to mention any names.
Okay. But this doesn't apply to that. So what he means by checking is simply input, output, correct, check. This is not checking how you're setting up the test or what you're doing in executing that test. He's simply saying input in, output out, it's correct, check, it works. And so what he's referring to, and what other people who are doing that are referring to, I think is something very different. I don't think that Michael Bolton will not advocate using checklists as a means to set up your test environment, to understand that the parameters are where you want them. What I think that these folks do is that they say that, you know, we're as testers, we're paid decent salaries, we have good education, we should be doing more than just saying the output is what we expected, we're okay with that. We should be doing some analysis there too. So I think that that's what that crowd is saying right there. And like I said, I don't think that Michael Bolton will say don't use checklists in some aspects of testing, but don't just be a checker. Don't just be someone who says, I got the output I wanted, this works.
Right. Okay. That makes sense.
So I have 4 overarching lessons to end up with here. First of all, everyone on the team, I'm emphasizing this again, everyone on the team has value to contribute. The leader doesn't know everything. Your automation sometimes lies like a rug, and keep situational awareness at all times. First, and you know, okay, well, I'll wait to further address that point, Phil, when I get to the end of the slide here. Everyone has value to contribute. Sometimes that value can be hard to quantify. Your tester may be your only domain expert. I know, you know, if it's a financial trading application. Oh, I was a I was a trader for 3 years before I got into IT. So you don't know that unless you work with these folks and talk with them. Your production person is also your best scriptwriter, perhaps. Use those, understand those skills, use those skills, and maybe it's kind of gone out of vogue over the last few years, but companies used to try to develop skills banks where people would say, my primary skill is X, my secondary skills are Y and Z. And I'm also going to say this because one of the things that I think is the future of testing is that while we will have a primary skill, we're also going to be expected to develop secondary skills. Example I read recently in the Atlantic magazine was with the U.S. Navy, where they had a destroyer-like ship, which would typically have a crew of several hundred. They were experimenting with crews as small as 40 or 50. And in doing so, what these crews were supposed to do was they were supposed to have a primary skill on board ship, and then 2 or 3 other secondary skills that they could use to fill in for perhaps another person. And they found that this made the, now it wasn't all positive, but and you could read this, it's in the current issue of the Atlantic magazine. But what they found was that this made the entire crew and shipboard operation in general more agile, which I think is what we're trying to shoot for here. Sometimes your team needs to unlock that skill. The leader doesn't know everything. I think more and more, especially today, the leader is the final authority. It's my way or the highway doesn't exist. Or if it should exist, if it does exist, it shouldn't anymore. I think a testing team leader is part coach, part advocate. Make sure that the team is performing at a high level while also being able to remove impediments, remove roadblocks from doing what they need to do. The leader weighs recommendations and makes the final decision, but I think major decisions are primarily a team effort today. Your automation can lie like a rug. It's usually user error. Your automation may fail or may return results that aren't that are systematically biased against reality. It's usually user error in that maybe you don't know how Selenium or Cucumber or whatever the tool that you're using is really supposed to work at a deep level. Perhaps you're like me and you've never bothered with the manual, or you didn't receive training. But you came to rely on that automation rather than your own screws, your own skills. But ultimately, there may come a time, and I'm not saying it's definitely going to happen, but there may come a time when your automation screws you, and you don't know it because you didn't know how to do it manually. I fall back to what Nicholas Carr said at the keynote address that I saw a couple of years ago. If you haven't done it yourself, you can't trust your automation. Situational awareness. What is, in fact, situational awareness? It's our perception of the environment around us and the events that are occurring around us, the understanding of what they mean, and the projection of their status. Particularly, I don't know what you might do, but on the highway, when I'm driving down the highway, I look at all the cars around me. I spend maybe a fraction of a second looking at every single car around me and say, what am I going to do if this guy swerves into my lane? Or what am I going to do if the person in front of me brakes suddenly? So that's situational awareness. That's understanding where you are, what you're doing, everything around you, and what you might need to do in response to others or other circumstances. Know where you are at all times. Know your environment and your interaction with it. Know what you need to do.
So how does that translate into us as QA professionals? What types of situational awareness do we usually forget, or should we make sure that we account for?
One that I'm encountering in a project right now is that there's a group that does testing, integration testing, and sometimes they don't always look at the test environment. Have they reset the test environment to a clean state? Should they be setting the test environment to a clean state, or should they be testing this in in some sort of dirty or contrived state, or partially executed state? Understand understand what your test environment is supposed to look like, and know when you're running a test, does it really look like that? Just don't blindly run your tests.
Okay, well, that makes a lot of sense. I think a lot of times we test in, I guess you say we try to set up a fairly clean test environment, but that's not really the way it is in real life.
And that's not all the case. I remember in a company I worked for years ago that we would literally have dozens of images, and we would some of those images would intentionally be in a partially completed state or a partially executed state, so that we had the ability to run our tests in a dirty environment. Anyway, so as a final lesson, I'd like to point out that we as testers, like aircrews, we're members of a team. So you should, what I'd like to leave you with is that you're not Superman. You're not expected to do everything in a project. If you are, I really feel sorry for you. But you're not expected to do everything and know everything. You are not alone. So with that in mind, I've given this, I have some conclusions here, and they're pretty straightforward. Crew resource management can be applied to testing, and not only testing, but Agile and DevOps teams. Practice non-conforming situations. Make up crisis scenarios. Make up something's gone wrong scenarios. Make up stuff scenarios. Chances are they will happen at some point in time. Imagine them ahead of time, and maybe write down some procedures that you would do. Maybe talk about it amongst your team. Your structured practices, things like this, structured practices and structured communications may work boring. We all love to be a hero. Face it, we all love to be a hero. Prepping ahead of time may make our jobs more boring, but they really help when things start going wrong. So I kind of have a last slide. I've given this at conferences, and I say now, as you're flying home, think about how you might apply this to the day-to-day work of your testing team. I think few, if any of you, are flying from a virtual presentation. So just try to imagine yourself sitting back, relaxing, maybe with a drink in front of you, thinking, uh, how can I take some of these concepts and maybe start using them tomorrow? Thank you very much. Thank you, Phil.
Thanks, Peter. If you could just go to the next slide there, and we'll just close up the webinar. We do, as I said in the beginning, we will be sending you information on the recording as well as the slides and posting things on our social media. If you have questions, please send them to us via Twitter or email. And we look forward to seeing you at the next quarterly webinar. Thanks very much, Peter, for sharing your knowledge on testing and how we can use air crews and their lessons in our careers. So thanks very much, Peter.
And thank you for having me, Phil. And I'd like to thank the audience once again. You've been great.
Okay, thank you.
Thank you.
Bye.